Okay, good morning, students of grade 9 from Kumudini Secondary School. Today we are going to continue our simple machine lesson, and this would be your last class on this topic, simple machine. We're going to discuss law of moment. Now, think about a door. Yes, if you look at a door from top, a door is somewhat like this, isn't it? And here it is clamped. The door is clamped over here. Yes, and handle is kept somewhere here. Okay, so if you grab the handle and you pull the door, it will open. Yes, if you apply force over here at this point, then here it is hinged at this point, and you apply effort over here, then the door opens. And when it opens, you must notice that it always takes circular path, or it always takes rotatory motion. It does not move in a straight line. Why? Because it is hinged at this point. Okay, if you attach a marker at the tip of door and then you open, then the door will always form curved path, a circular motion. Okay, so what you are saying that if you apply force on this door, then it shows you the rotatory motion or turning effect. Getting it or not? Okay, and when force is applied, if the force shows the turning effect, then that turning effect of force, it is called moment. Okay, so it is very simple. What is moment? Moment is the turning effect of force. Now if you apply at the point at the tip of door, then you have to apply less amount of force to open the door, okay, to produce a turning effect. However, if you put a handle over here, if you fix handle near the hinge, this is called hinge, isn't it? If you fix the handle near the hinge, then to open the door you might need to apply even a lot of force. Okay, larger amount of force is needed to open the door to produce the turning effect on the door. Got it? Now what is the difference? Why is it happening? Why you need to apply larger force to produce same amount of moment, same amount of turning effect when handle is placed near the hinge, and why you need to apply relatively less amount of force to produce same turning effect when handle is kept at the tip. And what happens if handle is kept at somewhere at the middle? Then the force you need to apply will be less than here, okay, and more than here. Understood or not? So what I am saying is, if the distance between fulcrum and the point where force is applied is less, then you need to apply more force to produce same amount of moment. However, if the distance between the point at which force is applied and the fulcrum is more, then you have to apply less amount of force to produce same moment. Okay, so it shows that moment, the turning effect or moment, it depends on two factors. Yes, first of all, it depends on force. Okay, more you apply the force, if you apply more amount of force, then greater moment will be produced. If you apply less amount of force, then lesser moment is produced. At the same time, moment is also proportional to distance. A distance that is called moment arm. Okay, and this is indicated by F, this is indicated by D. Okay, moment arm. See, if moment arm is longer, then it produces more moment. If moment arm is shorter, then it produces less moment, and that moment is not enough to open the door. So to produce enough moment, you have to apply more force. Okay, so moment depends on two factors, force and moment arm. Okay, are you getting or not? Let me explain again. To open the door, you need certain amount of turning effect, or you need certain amount of moment, and that moment primarily depends on amount of force applied. Okay, but if moment arm is long, then you need to apply less amount of force to open the door. But if moment arm is short, then if you apply same amount of force at this position, then the door will not open, because that moment will not be sufficient. And to produce enough moment to open the door, you need to apply more force if you apply force at this point. Okay, so moment depends on two factors, force and moment arm. So here then what you get is moment is equals to F into D. Okay, moment is equals to F into D, and moment is defined as the turning effect of force. Okay, and mathematically moment is equals to F into D, and its SI unit SI unit of moment is, you can easily tell it, SI unit of force is Newton, and SI unit of distance of moment arm is meter, Newton meter. Okay, now come to practical life experience. You might have tried to open a knot by using a spanner. Yes, spanner, this is called spanner. Okay, and knot so knot is somewhat like this. Okay, to open the knot, you need to fix a spanner in the knot, and then you need to apply force. Okay, because the knot remains fixed over here at this point, so this point acts as the fulcrum. Okay, and you apply force, effort at this point. Then when you apply force here, it produces rotatory motion. Yes, it produces turning effect, and because of that the knot also rotates and the knot gets opened. Yes, however, now try this. You have opened a knot by using force over here several times, so this time try to do the same by applying force over here. At this point, what happens? Notice it. Okay, it might be even impossible to open the same knot by applying force over here than by applying force over here. Okay, because by applying force here, it will produce less moment. By applying force here, it will produce more moment. And if the knot is very much tight, then you might need to apply force at several points. Yes, with one hand you apply force at this point, with another hand you apply force at this point. Okay, in this way, if you apply effort in two different points, then both of them produce their individual moment. Okay, it also produces moment, and this force also produce moment, and this moment gets added up. Okay, the moment produced by effort at this point and moment produced by effort at this point will be added up, and with that total sum of moment might be sufficient to open the rusted knot. Okay, or alternatively, to open up a rusted knot, what you can do, so if the knot is too much rusted, then you can use a long spanner. Okay, longer spanner produces longer spanner has longer moment arm, and it produces more amount of moment. Yes, however, the risk is, if the spanner is too long, then there is high chance of breakage. The spanner could be broken at the middle if it is too long. Yes, it should not be too much long. Indeed, what we do, we apply energy at multiple points to produce multiple moment that will get added up. Okay, now if you can lend a hand from your friend, then you can apply energy, or you can apply force in even more points. Okay, you can produce 3 or 4 moments that will eventually get added up to open up the knot. Got it? So a moment can be produce at multiple points. Okay, in a same device we can produce multiple moment at multiple point, and this moment they get added up. Okay, that was an example of device. Okay, that was an example of device which is hinged at one of the end. It is something like load is in middle means second class lever. Yes, it is something like second class lever. Now in a device which is like first class lever, let's discuss about it. In a device which is like first class lever, it is hinged at this point. Okay, that means it rotates at this point. If you apply force over here, it rotates in this direction, isn't it? And if you apply force over here, then it rotates in this direction. Okay, wherever you apply force, they rotate. But what you can see, if you apply force here, it rotates in the direction of clock. Yes, you know the clock, the hour hand or minute hand of clock, they rotate in this direction, isn't it? Yes, so the direction in which in which the hands of clock rotates, that is called clockwise direction. Okay, and the direction opposite to the clock is called anti-clockwise direction. So when you apply force over here, it rotates in the direction of clock, so it is called clockwise moment. And when you apply force at this point, it rotates. This force rotates the device in opposite direction of clock, so it is called anti-clockwise moment. Okay, now if the clockwise moment and anti-clockwise moment, they are acting in opposite direction, means they can cancel up each other. Okay, when the moments are acting in same direction, they can be added. Yes, in the same manner, when the moments are acting in opposite direction, they can cancel out. Okay, now if clockwise moment and anti-clockwise moment are equal, then the device is balanced. But if anti-clockwise moment is more than clockwise moment, then the device will rotate or fall through this direction. If clockwise moment is more than anti-clockwise moment, then the device is rotated in this direction. Okay, there will be a result. Okay? However, in a device at any point, suppose in this direction, you can apply force in 3 point. You are applying force in 3 point. Okay, this is point 1, point 2, point 3. Then these 3 forces, they all produce a clockwise moment. Okay, and here also you can apply force in multiple points, E4, E5. Then these will also produce anti-clockwise moment. Now you need to check whether the device will be balanced or not. You need to take total amount of clockwise moment. Okay, you need to add M1, M2 and M3 to find out clockwise moment, because as I told you, if you apply force at these 3 points, then the moment, they will produce moment in same direction, means they will get added. Okay, so clockwise moment will be M1 plus M2 plus M3. They will be added. And here also M4 and M5, by applying force at point 4 and 5, both of them produce anti-clockwise moment. So you need to find out total anti-clockwise moment. So total anti-clockwise moment will be M4 and M5. Okay, so if the total sum of anti-clockwise moment and total sum of clockwise moment are equal, then this device will be in equilibrium or balanced state. If clockwise moment is equals to anti-clockwise moment, the device is balanced or in equilibrium. Got it or not? In any device, by applying force at multiple points, at some point the forces produce clockwise moment and at some point the forces produce anti-clockwise moment. Okay, now if the total clockwise moment produced on the device is equals to total anti-clockwise moment, then the device is balanced or equilibrium. Okay, if they are not equal, then the device is not in equilibrium. Now this is called the law of moment. Law of moment. This is the law of moment. Okay, so law of moment states that in an equilibrium state, equilibrium means balanced state. Okay, total sum of clockwise moment produced on a machine is equal to total sum of anti-clockwise moment. Okay, this is the statement of law of moment. In an equilibrium state, total sum of clockwise moment produced on a machine is equal to total sum of anti-clockwise moment. Okay, now we will use this law of moment to perform some numerical, but before that, one very common question I want to discuss. The tall trees, there is a tall tree, okay, and there is a short tree, short and stout tree. Okay, and there are two trees, tree A and tree B, tall tree and short tree. And when strong wind blows, then we all know that there is greater chance of breaking of tall tree than the short tree. Why is that? Why is there greater chance of breaking of tall tree during strong wind or storm than short tree? Because you can say the wind provides equal amount of force. Yes, on both tall tree and short tree, wind provides equal amount of force. Whereas in case of tall tree, the moment arm is larger than moment arm in short tree. Tall tree has more or larger moment arm. So wind produces greater moment on tall tree compared to short tree. Okay, because of that greater moment, the tree is easily broken. Tall tree is easily broken, but not the short tree. Can you give that answer? I hope so. If not, rewind the video and copy the answer as in dictation. Okay, now we are going to confront some numerical problems. Okay, this is actually very easy one. Although it is long, it is very easy numerical. Once it is explained, anyone can perform this numerical quite easily. Okay, you are given a simple machine, a first class lever in which three loads are hung. The first load is hung at point A. Okay, that is of 20 Newton weight. First load has 20 Newton weight, and second load is hung over here at position B, and it is 40 Newton weight. And third load is placed over here, it is 20 Newton of load. So you can see in this lever, on the left side of lever, only one load is fixed, that is of 20 Newton, and in the another side of lever, two loads are fixed, they are 40 Newton and 10 Newton. And more information is given here. The distance between load A and fulcrum is 30 centimeter. Okay, load A is placed 30 centimeter away from fulcrum, and load B is placed 5 centimeter away from fulcrum, whereas load C is placed 20 centimeter away from fulcrum. Okay. Now just by looking at this, we cannot tell whether this device will be in equilibrium or not. The question is number A. Check if the device is balanced or not. Okay, first of all you need to check it, and if not balanced, how far, okay, this is C, should load C be shifted to balance it? Okay, there are two questions attached to it. First of all, you need to check whether this system will be imbalanced or not. Okay, and one side 30 centimeter far from fulcrum, 20 Newton load is suspended, and in another side two loads are suspended. One has 40 Newton, which is 5 centimeter away from fulcrum, and another has 10 Newton weight, which is 20 centimeter away from fulcrum. If you simply check the weight, then you can say that at this part it has 2.5 times more weight than this part. Yes, okay, so but that alone will not tell us whether it is in equilibrium or not. Had the loads been placed at equal distance, then we might simply look at the loads, okay, and tell it whether it is balanced or not. But since they are placed in at different distance, we cannot tell it. Okay. Now let's go to solution. For load A, force, how much force does it have? F1 or FA is equals to 20 Newton, and moment arm means distance between load and fulcrum. It is indicated by DA, means this moment arm of A. It is 30 centimeter, but you must convert it in to SI unit, that means 0.3 meter. Okay, and for load B, force or FB is equals to 40 Newton, and moment arm, I'm just writing taking up given information, dB is equals to 5 centimeter, that means 0.05 meter. Okay, and for load C, force FC is equals to 10 Newton, and moment arm DC is equals to 20 centimeter, that is 0.2 meter. And according to the diagram, okay, look at the diagram, you can see that load A, it produces anti-clockwise moment, isn't it? Load A tends to rotate the machine through this direction, that is anti-clockwise direction, whereas load B and load C, they produce clockwise moment. Okay, we need to write it down. Load A produces anti-clockwise moment, whereas load B and C produce clockwise moment. Okay, so now calculate this clockwise and anti-clockwise moment separately. Then anti-clockwise moment is equals to the moment produced by A. Yes, load A produces anti-clockwise moment, means moment produced by A. Okay, moment produced by A, which means, you know, the formula of moment is force into moment arm. That means FA into DA, and that would be FA how much? 20, and DA 0.3. 20 into 0.3, and it shall give you 6 Newton meter. Okay, any confusion up here? Okay, we just calculated the moment produced by A, that is anti-clockwise moment. This is ACM, whereas load B and C produce clockwise moment CM. Okay, now we are going to calculate clockwise moment. And clockwise moment is equals to moment produced by, look at the figure again, B and C. Okay, clockwise moment, both B and C produce clockwise moment, so total clockwise moment would be moment produced by B plus C. So moment produced by B, FB into DB, plus moment produced by C, FC into DC. Now get the data from the figure once again. FB is 40 Newton, FC is 10 Newton. Okay, FB is 5 centimeter and FC is 20 centimeter. So FB would be 40 into DB would be 5 centimeters. That means 0.05 meter. Plus FC 10 into DC 20 centimeter means 0.2 meter. Now it will give us 0.05 into 40. The 0 cancels out decimal over here. 4 into 0.5 means 2. Okay, and 10 into 0.2 means 2. It also gives 2 means 4 Newton meter. Okay, so total clockwise moment is 4 Newton meter, whereas total anti-clockwise moment is 6 Newton meter. See, so in this case, this one, load A produces anti-clockwise moment. Load A produces a moment of how much? 6 Newton meter. Okay, whereas combinedly load B and C produces only 4 Newton meter of moment. Now see, you can easily see that anti-clockwise moment is more than clockwise moment. So this device will turn in anti-clockwise direction. It is not in equilibrium. Okay, so to give conclusion, since anti-clockwise momentum is larger than clockwise momentum, the device is not in equilibrium state. Full stop. It rotates in anti-clockwise direction. Okay. Now come to second part of question. Again, by shifting, the second part of question says that if it is not balanced, yes, if it is balanced, then we don't need to go to second part of question. We don't need to solve this if it is balanced. But since the lever is not balanced, we need to solve the second part of question. It says, if not balanced, how far should load C be shifted? So to balance it, you need to shift load C, whether closer to fulcrum or farther than fulcrum. We don't know that, but we can assume that we don't know the distance of C from fulcrum. Okay, to what distance it should be shifted to make it balance from fulcrum, we don't know that. So by shifting load C, we can say DC is equals to what? Yes, DC means moment arm of C is equals to what? Okay, now according to the law of moment, anti-clockwise moment is equals to clockwise moment, or in an anti-clockwise moment, what anti-clockwise moment is produced by A, that means FA into DA, and clockwise moment is produced by B and C. Yes, we have already encountered that. That means FB into DB plus FC into DC. Now all factors remain same except for DC. Yes, FA is 20 and DA is 0.3, FB is 40 and DB is 0.05, FC remains 10 but DC we don't know that. Okay, or this gives you 6 and this gives you 2 plus 10 into DC, or if we shift 2 to the other side, then it will be subtracted. Okay, you get this, or 6 minus 2 equals to 10 into DC, and if you shift 10 to the other side, it will be cross multiplied, that means divide. Therefore DC is equals to 0.2 meter. that means 20 centimeter. See, if you want to balance this lever, I'm sorry, what am I getting? Sorry, 6 minus 2 is 4. Okay, my bad, I made a mistake. 6 minus 2 is 4. 4 by 10 means 0.4 meter, that means 40 centimeter. Okay, sorry, that is my bad. Okay, here, if you want to balance this lever, you must shift the load C up to 40 centimeter away from fulcrum. Okay, if you want to balance the lever, the load C must be shifted up to 40 centimeter away from fulcrum. Okay, give the conclusion. Therefore, the load C should be shifted up to 40 centimeter away from fulcrum to balance the lever. Okay, that's it. What if you don't understand, please go rewind the video. You can always do that. Yes, that is the charm of using recorded video for your online class. Okay, now if you need to copy it, I'm going to show the steps again. Okay, you just pause the screen and copy it. It's the question. The given informations, pause the screen and take it, copy it, and then first step we are calculating anti-clockwise moment. Next one, calculation of clockwise moment, and the conclusion or analysis. Next one, shifting, this one, and the final step. Okay, if you have copied this much, now we have completed our lesson on simple machine. Okay, and we need to take exercise. Okay, I'm going to send the picture of exercise from book to your messenger group as well, but you can take it from here as well. You can always pause the screen and copy the question. In YouTube you can also download the video so that you can watch it again even when there is no Wi-Fi. Okay, download the video, go to the place where there is Wi-Fi, download the video, come home, and then you can watch it. Okay, are you taking the question or not? Okay, this lesson has a lot of exercise. You need to be patient. Okay, I'm giving you 2 days to complete the exercise. I'm sure you cannot finish it within 1 day. Single day is not enough to finish all this exercise. Okay, once again, you know what to do. Go to the place where there is Wi-Fi, download the video, come home. Okay, and then you can watch it offline by opening YouTube app. Okay, open the YouTube app, and there is an option to watch offline video. You can watch it and then pause wherever you need to take out the question. Okay, thank you class. Today only this much.